The world we live in is a complex web of logistics. Every time you order a package, every time an airline schedules its fleet, and every time a city manages its power grid, a computer is trying to find the perfect solution. In computer science, we call this an optimization problem. We have been using classical supercomputers to solve these for decades, but we are about to hit a wall. As our world becomes more connected, the number of variables is growing faster than our chips can keep up. We are entering the era of the quantum advantage, where the way we organize our civilization will shift from good enough to mathematically perfect. To understand the difference between how a classical computer and a quantum computer solve a problem, imagine you're looking for the lowest point in a massive mountain range in the middle of a pitch-black night. A classical supercomputer, even one that fills an entire building, is like a person with a flashlight. It starts at one point and walks down the hill. When it hits a valley, it looks around. It thinks, this is the lowest point I can see, so it must be the answer. But it has no way of knowing if there is a much deeper valley 10 miles away behind the next peak. To find the true global minimum, it would have to walk every single inch of the mountain range. For a global shipping company managing 10,000 ships and millions of containers, the mountain range of possibilities has more paths than there are atoms in the universe. We call this the combinatorial explosion. Because classical computers cannot explore every path, they use heuristics. Essentially, they take a shortcut. They give us an answer that is 90% correct because calculating the final 10% would take 1,000 years. That 10% gap represents billions of dollars in wasted fuel, tons of unnecessary carbon emissions, and massive inefficiencies in our global supply chain. A quantum computer does not walk the mountain range. It behaves like a fog that covers the entire range at once. This is the power of quantum tunneling and superposition. Instead of checking one path at a time, the quantum bits or qubits can represent every possible path simultaneously. Through a process called quantum annealing, or the Quantum Approximate Optimization Algorithm, the computer uses quantum interference to drain the probability away from the high peaks and pull it into the deepest valleys. It finds the absolute lowest point, the perfect solution, almost instantly. Let's look at the real-world impact of that 10% efficiency gain. In the world of aviation, gate assignment is a nightmare. If a plane is delayed by 5 minutes in London, it ripples through every airport in Europe. Classical computers struggle to recalculate those ripples in real time, leading to those hours-long delays we all hate. A quantum computer could re-optimize the entire global flight schedule every second, ensuring that the system absorbs the shock without a single person missing their connection. In the world of medicine, we can use this to optimize protein folding. Diseases like Alzheimer's occur when proteins in your body misfold into the wrong shape. Trying to calculate the correct shape of a protein is an optimization problem of such staggering complexity that classical computers simply cannot do it accurately. A quantum computer could solve the protein, showing us exactly where the fold went wrong and how to design a molecule to fix it. This is the shift from trial and error to precision. In the 20th century, we built a world that worked. In the 21st century, quantum optimization will allow us to build a world that is efficient. We are talking about traffic-less cities, zero-waste supply chains, and power grids that balance themselves in microseconds. The nations that master quantum optimization will be able to do more with less. They will use less energy, less time, and fewer resources to achieve better results. It is the ultimate competitive advantage. We are no longer just trying to build faster machines. We are trying to find the best possible way to run our planet. The era of the perfect solution is almost here.